All right, here's an example 2 for the first derivative test. And we're to state the domain first. So this is a rational function, and it has, we have to exclude x equals 2 because there's a vertical asymptote at that point. It's undefined there. So the domain is all reals except for x equals 2. All right, and then determine any local extrema using the first derivative test. So recall that that means that the first step is to find the critical values that are in the domain of f of x. Now, okay, so why in the domain of f of x? Because if you're trying to locate extrema, you're trying to find points where the function is defined and has a peak or a valley, right? So it has to be in the domain for that to happen. Now, the first derivative, so you can have a point in the domain of f of x where the first derivative, it is undefined. So it's not contradictory to find where the first derivative is undefined, because think of like cusps, right? Something like that. It's defined at the cusp point, but the first derivative wouldn't exist there. So, but we still have, like in this picture, a relative max. So we're not being contradictory there, but we do want to make sure we understand if it's not in the domain, it can't be a point on the graph, and therefore it can't be a critical, it can't be an extrema. All right. So enough of that. Let's go ahead and do the first derivative. So, whoops, I always want to write g. Might be helpful to rewrite that function. So g of x could be rewritten as x minus 2 to the negative 1. So writing it as a power and then take the derivative. So that would be power rule negative 1 times the base and subtract 1 from the base, from the exponent of the base, that's negative 2. Now I multiply by the derivative of the inside, which is derivative is 1. And so that gives me negative 1 over quantity x minus 2 squared. Okay, so this function is, it has a critical point, right? So there's a critical point. Its critical value is when g prime is equal to 0. Well, it's never equal to 0 because the numerator is never 0. But it is undefined at x equals 2. So that's definitely a critical value. But in this case, that's also a vertical asymptote of the function. And therefore, it can't be an extrema. So we have to exclude this. And so that means that there are no critical values in the domain of the function. In the domain of g of x. And so what does that mean? That means there can be no extrema. Not only that, so even though I haven't done the number line test, I'm actually just completely skipping doing a number line test. I can tell that the first derivative is always going to be negative just by looking at the numerator is always negative and the denominator is always positive because of that square. And since this is always negative, we also know that g has to be decreasing everywhere. G is decreasing on the entire domain. Because g prime is less than 0 everywhere, right? Now, they didn't ask us to find that. All we had to do was find local extrema, and we didn't find any. So we checked we've done that, and we listed our domain. So really, we've answered the question right here. Right? And take a look at the graph. You can see that as we move from left to right, this function is decreasing up until the vertical asymptote. So here's x equals 2. So there's a vertical asymptote here. So it's decreasing everywhere on the left. And then as I move left to right, the function g is decreasing. So this is the graph of g of x. And it's decreasing on the right side of the vertical asymptote as well. So, but there's no extrema. Even this, it looks like a little bump. That's not a high point because remember, it's decreasing everywhere. To be an extrema, you have to rise, then fall, or fall and rise. And we don't have that here. So there are no extrema for this function.